particular question. They say find x. Log x to the base 2 plus log x to the base 4 equals 6. You can see there's a problem here. The base over here is 2, but the base over here is 4. And you can't solve it straight away like this. Therefore, we have to change the base over here to 2. But we don't just change it anyhow. Let's see how to solve this problem. So in this case, we have log x to the base 2 over here, plus, so here we change the base to base 2 because there's a base 2 over here already. The first thing for me to do is to change the base over there to base 2 so that it will be easier for us to solve it. Okay? So here we use the change of base, and our new base is base 2. So we take log to base 2 x out of log to base 2 4, or log 4 to the base 2. Okay, to change the base. And this equals 6. Okay. So we have log x to the base 2 plus. Now let's look at something here. Here is 4. This 4 can be changed to what? 2 exponent 2. Okay, so we are going to have log to base 2x. Here is going to give us log to base 2 squared, right? And this equals to 6. Okay. So over here we are going to have log x to the base 2 plus. So here we could see that when we apply the laws of logarithm, these two come back to multiply the log. I will be having log 2 to the base 2. And log 2 to the base 2 will give us 1. Okay? So the 1 will multiply these 2, which will be at the back. And we are going to have log x to the base 2 out of 2, which is equal to 6. So at this point, what we do, this is a fraction. Okay? A denominator of 2. So we multiply 2 by the denominator, which is 2. Over here, and this is going to give us 2 times plus times 2 equals 6 times 2. Okay, so this 2 will cancel this 2 off, and we are going to have this 2 is multiplying the logarithm. This 2 is going to go back to its original position, which is the exponent. Okay, so it will climb the x for me to have x exponent 2, the base 2. Okay, here is left with log x, because this will have cancelled this one off. So plus log x to the base 2, and this is equals to 12. Okay, so that's what we have. Log x to the exponent of 2 to the base 2 plus log x to the base 2 equals 12. Now you can see that the bases are now the same. Okay, and therefore we can apply the law, the addition law of logarithm. So when the bases are the same, we take one of the log, then we multiply the values. So we are going to have log x squared times x, okay, equals 12. So here we have to the base 2 over here. Okay, so when we do the multiplication, we are going to have log x cubed to the base 2 equals 12. So at this point, we convert everything over here to indices. So we have a base of 2, the base is 2 over here, exponent of 12 equals x cubed. Okay, so 2 exponent 12, what are we going to have? 2 exponent 12, and it's going to give us what? 1496, right? Equals x cubed. So over here, what do? We take the cube root of both sides. Cube root. So just to cancel this one off. Now cube root of 4096, which is going to give us what? Okay. So we have 16. So 16 equals x. 16 equals x over here. Or better still, you can write it as x equals 16. This is our value of x, as the question demands.